Hello students, welcome back to my chemistry lecture on thermodynamics. So in this video, I'm going to discuss about the second law of the second law of thermodynamics. Thermodynamics. In my previous lecture, I was talking about the first law of thermodynamics, change in internal energy, enthalpy, I was discussing. But in this lecture, I'm going to talk about entropy, which is the central idea of the second law of thermodynamics. For the formulation of second law of thermodynamics, we need to discuss about entropy. The symbol is S, capital S, or entropy change can be taken as delta S, we write. As you know that several things happen in the nature spontaneously, or naturally. Some things do not takes place spontaneously. Some things happen spontaneously, naturally. Some things do not takes place spontaneously. Do you know why? For example, for example, for example, waterfall, waterfall, waterfall from greater height to down. And the sudden fall of stone from the height, sudden fall of the stone. And if you consider some chemical reactions, so change of even diamond to graphite, though it is very slow, but reaction is spontaneous. Reaction is spontaneous. Reaction is spontaneous. Or sudden distribution of gas, or what we can say, so gas diffusion, we say gas diffusion is spontaneous and occupy the vacuum, chamber. So sudden diffusion of the gas is also spontaneous change, we can say spontaneous change, we can write. So just I mentioned the spontaneous examples I have given here. First of all, what is spontaneity? What is spontaneity, first of all? So process takes place two ways, naturally. The process takes place, process we can classify two types. One is spontaneous process, other one is non-spontaneous process in the nature. Spontaneous process, spontaneous and non-spontaneous process we can classify. What is a spontaneity first of all? The spontaneity can be defined as, so having potential, spontaneity can be defined as, so potential, having potential to undergo change, having potential to undergo what kind of change this is? Spontaneous change, spontaneous change without external support, or without external agency, What is the spontaneity? The spontaneity can be defined as having potential to undergo a spontaneous change without external support or without external agency is said to be spontaneity, we call. That means, what does it mean? Without consuming energy or without external force, if any reaction takes place, if any chemical reaction, occur, okay, that is said to be spontaneity, we say. So I have given the definition of spontaneity. So now just now I have given the definition of the spontaneity. What is meant by spontaneity means, so having potential to undergo spontaneous change without taking the help of external agency is said to be. So some of the reactions occur spontaneously without supplying of heat energy. So such chemical reactions are spontaneous chemical reactions. Such chemical reactions are said to be spontaneous chemical reactions, we say. And these spontaneous chemical reactions are unidirectional or irreversible takes place only one direction. That means the spontaneous chemical reactions takes place unidirectional and irreversible, so happens only unidirectional change, unidirectional change we can write. But now my question is here, so what is cause for the spontaneity? So what is the driving force? What is the driving force? For the spontaneity of chemical reactions? What is the driving force? So what could be the reason for this? So here, if you want to know the driving force for the spontaneity, then we have to talk about entropy is a term, or entropy is the central idea. So which is the manifestation of what we call, or sorry, which is the uh, central idea of the second law of thermodynamics, we say. So heat energy is the manifestation of entropy. And now, so spontaneity, what is the driving force for the spontaneity? The main driving force is the entropy. Now, if we want to discuss about entropy, so then we have to talk about energy and matter we have to talk about. So during the spontaneity reactions, there is dispersal of energy and dispersal of matter. Or during the spontaneity, change of energy or a distribution of energy and matter takes place. Matter takes place. So then we need to talk about what is entropy and what is the second law, the definition of second law of thermodynamics. The second, now I'm going to define the second law of thermodynamics. So the second law of thermodynamics was defined by Kelvin scientist. We have to discuss the Kelvin statement. So what Kelvin has defined this statement: no process is possible. No process is possible in which the sole result is the absorption of heat from a reservoir and its complete conversion. It's a complete conversion into work. So the second law of thermodynamics says, according to the Kelvin scientist, no process is possible in which the sole result is the absorption of heat from a reservoir and it's a complete conversion into work. So this is the second law of thermodynamics. As per the scientist Kelvin has given this statement. So what it says indirectly, so without supplying up the heat energy. So without supplying of the heat energy, so no process takes place. That means heat is responsible for the change, or heat is responsible for the distribution of matter or randomness of the matter that is responsible. And now let me talk about other definition of the second law of thermodynamics given by Rudolf Clausius, scientist. According to the Rudolf Clausius scientist, so what is the definition of the second law of thermodynamics? According to Rudolf Clausius, heat does not flow spontaneously from colder body to colder body to colder body to a hotter body. Colder body to hotter body. This statement was given by Rudolf Clausius, scientist. Heat does not flow spontaneously from colder body to hotter body. That means to achieve the transfer of heat from colder body to hotter body, it is necessary to do some work. Then unless the work is done on the body, on the system, like work done on the system as in the work done in the refrigerator. So work done in the refrigerator for cooling purpose. So Rudolf Clausius was a scientist who defined the second law of thermodynamics. Heat does not flow spontaneously from colder body to a hotter body. So to achieve the transfer of heat to hotter body, it is necessary to do work on the system, right? So this is the second law of thermodynamics. So now, the central idea, I was talking about the central idea of the second law of thermodynamics is that, entropy. If you want to know, about the second law of thermodynamics, then it is necessary to understand about entropy or entropy change, thermodynamic entropy. As you know that entropy is an extensive property. This is extensive property. And it is also said to be a state function. It is also state function we can talk about. It is state function. And why it is said to be state function? Because it independent to the path and the entropy change means dependent on initial and final state. For example, the entropy delta S is equal to and initial, it moves from that initial to final. So then dq for the system is under reversible condition. Then entropy change is inverse to the temperature. We can write the equation. The entropy can be defined as what is the definition of entropy? So entropy can be defined as it is thermodynamic property. It is thermodynamic property we can define. It is the measurement of or measure of the randomness of a system. So measure of the randomness of a system. So our randomness motion of the system or surroundings. So is said to be what we call means entropy. So what is the cause for this? What is cause for the randomness of a system? So what is the reason? What is the cause for the randomness of the system? Then it comes to our mind only heat energy. That means if you supply heat energy, Q energy to the system, then the heat energy has random influence, or the heat energy increase the kinetic motion of the particles, kinetic motion of the molecules, and heat energy will so cause the randomness of the molecule, motion of the molecules. When the molecules start moving apart from each other. As a result of this, the molecules will start distributing, the matter start distributing, we say. That means, so is entropy change and Q energy are the same? So if you start thinking about entropy change and Q, they are not same. Then we need to talk about so supplying of this heat at given temperature. At given temperature, the temperature is responsible for the randomness of the matter, randomness of the system, we can say. That means here the entropy change is equal to Q upon T, inverse proportional relationship, we can say. That means, see, and for example, there is one system, A is the system, and having the molecules orderly molecules are present when at temperature T1 temperature, the molecules are arranged systematically, then Q energy is supplied to the system. Then the system will expand, or the volume of the system increases. Then molecules, kinetic motion of the molecules increases, the randomness increases, and the temperature changes to how much T2 temperature. Temperature changes to T2. So due to increasing of the randomness, then delta S equal to Q upon, so delta T, temperature difference, we can get entropy change. That means here entropy change is inversely proportional to delta S is inversely proportional to the temperature. And entropy change is directly proportional to the Q, heat supplied. That means the temperature difference will create that heat difference. Then the amount of heat energy will influence, or the heat energy that supplied to the system has a randomness influence. Randomness influence responsible for the disorderedness of the system. Disorderness or chaotic of a system